So this is a summary of the 7th International Workshop on Sea ice Modeling, Data Assimilation and Verification, which took place this last April at the European Space Agency. And it was a joint workshop between the International Ice Charting Working Group, the Polar Prediction Project, the WWRP Joint Working Group on Forecast Verification Research, and Godai Overview. And these are some of my notes from the meeting and some feedback from Xingrun Wu. And I was expecting Sean Helfrich to present the second half of this talk, to present his feedback from the ice charting perspective and ice analyst perspective. But I guess he can do that maybe another time. I've just lost the presentation. Thank you. So the focus of this workshop was to discuss cross-cutting issues in sea ice modeling and data assimilation, and also to discuss deficiencies of current systems and how they can be more efficiently diagnosed and addressed. And this was a very interesting meeting for me. I haven't been to the ice charting workshop before, and it was a real mix of people who are in the field doing the operational forecast, as well as people that are directly connected to the user community. So they were really focused and very productive discussions. And the sessions were focused on sea ice observations and uncertainties, sea ice data assimilation, sea ice model parameterizations and coupling in operational forecast models, verification approaches for sea ice analysis and forecast, and operational challenges and user needs. And it's usually a one-day meeting, but since there were so many different working groups involved, it was actually a 3-day meeting. And there were 37 oral presentations and 10 poster presentations. So I'm just going to present a few of the results from some of the presentations that I felt really crystallized the discussions that took place over this 3-day workshop. And the first was from Leif Peterson, and his talk was on satellite observations of sea ice concentration, and it was based on the results of the European Space Agency's Sea Ice Project on algorithm intercomparison. And if you look at the figure on the lower right, this is using all the different algorithms that people are using to construct sea ice concentrations, and using the radiances from ANSWER2 and ANSWER-E in determining when the algorithm produces open water. And you can see the huge spread over these different algorithms that are in use operationally. And one of the conclusions of this talk was that the sea ice forward models really need improvement. And one of the questions posed by the speaker was that maybe we shouldn't be assimilating retrieved parameters. Maybe it's better to assimilate the radiances. And so I thought that was a very interesting suggestion. That was something that the modelers, I think, are considering doing. The second, it was in my work, I do experimental sea ice forecasting at NOAA Esriel, and I use SSMI or ANSWER2 for my sea ice concentration and my initial conditions. And it was very interesting to hear about the SMOST satellite, the Soil Moisture Ocean Salinity satellite, which is operated by the European Space Agency. There are many other products that I learned about at this meeting that I wasn't aware of, and this one is very interesting because it does suffer from underestimating thin ice. It really has a problem detecting thin ice. It also has a pretty coarse resolution, about 25 kilometers, but it doesn't suffer from some of the problems of the other sea ice concentration products. It's almost transparent, so it's not really sensitive to atmospheric water vapor and cloud liquid water. And it also can see right through the snow. So it doesn't suffer from the problem of needing to estimate snow thickness when it's in its sea ice concentration product. Also, SMOST is used to construct a salinity product, which a few talks show that it would be very useful to use this product to determine the freshwater fluxes from the Arctic rivers into the Arctic Ocean. And they're also constructing sea ice thickness products from SMOST satellite as well. And it was really interesting to see how many of the operational forecast groups are beginning to assimilate not only sea ice concentration, but sea ice thickness, primarily cryostat and smoke. So this is from a talk from the Naval Research Laboratory, from the Norwegian Meteorological Institute and the UK Met Office. If they aren't already assimilating ice thickness, they have plans to within the next couple years. So that's something that will be in the operational forecast if it's not now very soon. And there were quite a few national labs represented at the meeting. This is just a subset. There were quite a few other models discussed. But these are some of the larger efforts, the ECMWF, NCEP, the Naval Research Laboratory, the UK Met Office, and the Environment Canada, and also the experimental forecast that we do here at NOAA Esrill. And one really interesting thing is that very few of these operational forecast models are coupled to the atmosphere. And that's a real issue because if you specify what the atmospheric fields are going to be, the ocean ice component to a large extent will respond to that. And so these modeling efforts are aware of this problem, and they all have plans to have fully coupled systems. But it was interesting to see how few at this time actually coupled to the atmosphere. So another really interesting discussion was on operational challenges and user needs. And this is from the Canadian Ice Service. And if you look at the lower figure here, it shows that there are very close connections between analyses and observations and database processing and verification and ice analysts. But there is very poor connection between numerical guidance and clients. And that's something that I'm very aware of with the work that I'm doing with these experimental forecasts and some of the interactions that we've had with the ICE desk in the National Weather Service in Anchorage. And so that's something that there was a lot of discussion how to make that a stronger connection. And this is a slide from that same talk. And it really covers many of the points that were discussed at the very end of the workshop when we were discussing the findings of the workshop. And one of the main issues is that clients really need probabilistic forecast information. So the operational forecasts really need to be ensemble forecasts. They also need higher resolution in order for the forecast to be useful. And also the sea ice data simulation has to more effectively include all the different sources of sea ice concentration. As I said, the SMOS and SSMI and AMSR2 should all be used together, and also to be using the higher order products such as SAR. And one really interesting point is that the sea ice models really need to have more complete physics. And an example of this came up in Greg Smith's talk from Environment Canada. He was talking about parameterizations of landfast ice and the significant impact that has on the scale of their forecast. So that was another issue that was discussed quite a lot at this meeting, is the physics is missing in the sea ice models and how to improve that. And we had some really nice discussions between the Canadians at the meeting and the Americans, so that's Environment Canada and then NOAA and the US Navy. And so we got together at a very nice Italian restaurant, and we discussed how to leverage our different activities so that we can fill some of these gaps, because there's so little funding in sea ice forecasting that we really need to pool our efforts to really produce skillful forecasts. And we came up with 3 points that are pretty basic that would significantly improve the forecasts that are done in Environment Canada and in the US. And the first was to share our operational and pre-operational models and our different parameterizations. And the second, which is really interesting, there's no WMO standard for ice model verification. So that was really, for me, at the top of the list, is really to together decide what is the best way to verify the forecast. And then after that is completed, to do a joint Canadian-American verification procedure based on this new WMO guideline. And so these 3 different activities will address some of these known problems with producing the best possible sea ice forecast. The first is that there's very uncoordinated in situ Arctic measurements, and they need to be in a database that's easily accessible. The second is that it would help us to develop a more systematic standard for quantitative error estimates. And so there are quite a few people on the line here who were also at this meeting. So if there are points here that you thought were really relevant that I didn't include, please speak up. So thank you for listening, and I'll take any questions.
Okay, thank you, Amy. So questions for Amy? Perhaps somebody is on mute and talking to themselves. Check your mute buttons. Okay, Amy, it's Martin again. I have a question. I am not a modeler. So could you explain the difference between verification and validation?
I guess in my mind, I don't really see much of a difference between verification and validation. I would use those words interchangeably unless someone else disagrees.
Martin, we've got a question from Florence coming in via chat.
What the verification?
Oh, I don't know.
Well, it depends.
Does anybody want to follow up on the validation, verification topic? Is there a difference? Is it an important distinction?
This is Cecilia. I guess I have a slightly different view. I think you might consider validation to be about the quality of the model, but a verification is about a specific forecast.
And validation might be more focused on the data sets, on the observational data sets themselves, where verification may be for the model forecast.
I think it's important that we understand these terms and they be used correctly, because there is a lot of carelessness in the use of language and words, and it can be very confusing, particularly to the non-specialists. So I just make a plea that we use the appropriate word according to the context. Anyway, Florence had a text question or a chat question, apparently.
What would the verification or validation data look like? There was, in terms of validating the observational products that are used to initialize the models or simulated, they were using more limited data for the validation, such as IceBridge, and campaign data, such as there was something called NICE that was discussed. So I think in terms of validating the products that are used in the data assimilation, I would say that the validation data would be more limited data sets by aircraft or campaign data.
Hi, this is Becky Heim with the Sea Ice program here in Alaska. Can you hear me?
Hi, Becky.
Hi. I just wanted to bring up that I think this is an outstanding summary. Thanks so much for sharing, Amy. And these collaboration notes that you have here on the slide I think are outstanding. I was wondering if you had considered attending this year's IICWG meeting in Canada. I think one of the focus points is going to be on sea ice forecasting and models, and this might be a great starting point for some of those discussions.
I wasn't planning to. If Sean Helfrich doesn't go, then I will.
Okay. Regardless, I think we can make sure that we bring this information and your discussions to the table. I think this is a great starting point, what you've accomplished with the summary from this meeting.
Well, with the Canadians, they were really, everyone was very optimistic about whether we can achieve these goals. They seem like they're very basic goals, and they will improve the operational forecast dramatically by sharing our resources.
I agree entirely. I think there's just so much going on at the ground level right now to get things spun up, and if we work together, we can lay the groundwork to build a really strong future of sea ice forecasting.
Exactly.
It's Martin, and I see a couple of other chat questions, one from Kathy Geiger and one from Cecilia. If you can see those, Amy, could you go ahead and respond?
Yeah, Kathy, can you say a little bit more? So what is the central point discussed at this meeting? I think one of the more interesting things from my perspective was just how people's perspective about errors in models, forecasts, and errors in data has changed. And that was really brought up in Francois Maisonnet's talk, so showing that we really realized that the huge uncertainties in the observational fields that are used to initialize the model. And I think part of that is that there's a number of different products now to compare, and also that comparison of the algorithms that I showed. And so I think people are changing their perspective. It's not just about using the observational data sets to constrain the models, but to understand the uncertainties in both the observations and the models.
Yeah, this is Kathy. The main point of the comment was that a very revealing part of the workshop was how robust persistence is in all of these forecasts. And so a large metric being evaluated, especially with the Navy model and other models, is how effective is forecasting relative to persistence, and what can we do to better understand the diagnostics that persistence can tell us, because therein lies an ability to forecast better by extending and extrapolating from known conditions to unknown conditions as a prerequisite for doing prediction. So there were a number of points in workshop, and I'm just curious, for you as a central large-scale modeler, how did you feel about that central outcome at the workshop?
Are you referring to seasonal forecasts?
I was referring to a number of the talks that were put up, especially with the Navy was very good with their talk in showing that they had some very good metrics to evaluate how does forecasting work relative to persistence.
Right.
And maybe, I know we have a couple of Navy folks on here who could, I know Neil was there, and he could maybe bring in that as a discussion. I think it was a very central tenet, because the idea was to think of how can we forecast, and the Navy talk was very well done, because it first said, well, how well do we do relative to persistence? Because that is currently our milestone benchmark for evaluating the capability to forecast. And I think that became a very central point in a number of the side meetings and the dinner meetings, et cetera. So I don't, maybe others who are on the list here could comment, because it was a central point to think about going forward when we forecast. What is the capability level we're looking for?
Well, I don't know.
And can we get more out of persistence?
Yeah, I don't know if Cecilia is going to be discussing this, but that's something the Sea Ice Prediction Network has found, and I think it was the most recent paper, that the models can forecast climatology, but not the variability. So I don't know if that's exactly what you're referring to, but it's a known issue.
So it's Martin. Perhaps you could continue this discussion offline. It sounds like you have something to pursue there. So we could move on. Cecilia, you had a question about SIPN and its observations page. Did the Frascati workshop attendees, are they aware of the SIPN observations?
I don't think so. I don't remember that being brought up in any of the talks, so I think that's a really good point.
How would you bring that to the attention of the Frascati workshop participants?
I guess the best thing would be to bring it up at the Canadian workshop, where most of the attendees from Frascati will be there.
Okay, sounds like a good opportunity. And Amy, there's a question from Wisław Maslowski about ice extent and other sea ice variables that can be used with respect to modeling. I'm sure you can see that on the screen. Do you have a response to that?
That was something I didn't discuss. There was a whole session on that. There are quite a few. It is nothing that people really decided on. Maybe that's something that could be part of this WMO standard for ice model verification. But there were quite a few talks about different ways to quantify ice state. And so it's an active area of discussion. And it's something that should be a part of this WMO standard. But nothing's been decided.
So what particular state variables were discussed as alternatives to sea ice extent?
Well, there were different ways to quantify ice area. And let's see what, I'd have to review the talk, but it was mostly ice area and estimates of snow thickness. Mostly it was different ways to estimate ice area and ice edge.
Okay. Are there any other questions for Amy before we move on to the next talk? Okay, it seems there aren't. So thank you very much, Amy, for giving the overview of the Frascati workshop. And